Hello, everyone, and welcome to the first mini lecture in our series on internal forces. We are starting today with continental drift theory. I have a set of slides that I'll be going over in order to teach you more about this. You should be on this document. If you are not already, take a second, pause the video and get there. Make sure that as we go through this video, you are looking at the questions ahead. You are looking to answer them as I give you explanations. These questions are going to help you when you come into class as we discuss these key points, so you're able to be informed with the rest of the class. So make sure you're paying attention to those questions. As always, because this is a video, feel free to pause, feel free to turn on the closed captions, watch it as many times as you need to in order to make sure you're really fully understanding everything. I also linked a video link right up here, just a further option for support. If you want to, if you're kind of not understanding or struggling to visualize in your mind how this process works, feel free to watch that video. It's a really good, short, concise, brief little narrative that kind of shows you a little bit more visually about how plate tectonics and continental drift work. If not, totally fine as well. If you feel like you're grasping it, we'll totally check when you come into class. You will see that the first question asks you, before we even begin talking about it, to write down 2 facts you already know about Pangea and or continental drift theory. So take a second, pause the screen right now and go ahead and answer that. Alrighty, folks. You should have answered question 1. You're ready to answer the next 3 questions as we go. As I said, we're going to be talking about continental drift theory. So continental drift theory is the idea that all of the continents used to be one giant continent. That giant continent was a massive supercontinent, and it was called Pangea. You can see in the picture on the lower left-hand screen down there that all the continents used to be together, that now they have slowly and gradually drifted apart to look like the 7 distinct continents that we know them as today. You can also see some movement going on. Kind of notice how they're shaped together like little puzzle pieces as we're thinking about how these continents did slowly drift apart. I want you to be thinking in your head about how you think people might have noticed that these continents used to be one. Start kind of trying to formulate in your head. You don't have to write it down, but just start to think a little bit, because this is going to help you in class. How would we have known that these continents were once fully together as one supercontinent? How do we know that the Earth used to all be together in this way and it's changed now? So a little bit about how continents have drifted apart over time and how that has happened. That's happened through something called plate tectonics. You can see on the right-hand side of the screen with this map, all of those continents that we know today. And you'll notice that they all sit on things called plates. There is a theory that Earth's crust floats on top of magma. Remember all of those Earth's layers? Magma is going to be that like molten kind of liquid crust. Think of like a slushy or a smoothie, something like that. It is hot, so it is usually moving around, and the continents are sitting on top of that. Think about yourself in a pool, whatever temperature you love that pool to be. You are on a raft. When the water underneath you moves, you also move because the raft is moving. That is exactly how plate tectonics works, because the plates that hold up the continents are on top of that magma. So when the magma moves, when it's circulating around underneath, the Earth's crust and the plates are also moving, which can cause all different types of things to happen to the Earth. When we have plates moving, we get things like mountains, we get things like earthquakes, we get things like volcanoes, ocean ridges, trenches, tons and tons of things that we think of as huge kind of catastrophic events to the Earth's surface. Those all happen because of plate tectonics. So at this point, my friends, you should have these first 3 questions answered. If not, feel free to rewind, feel free to pause and take a second, answer those guys. Again, that video is there for your extra support if you do decide you need it. And then finally, the last thing I want you to do today before we go is to make a guess. Looking ahead at the names of all of these different types of plate movements, we talked a little bit about what those can cause. Which one do you think will be the most destructive to Earth's surface and why? Totally fine if you're not sure, but I want you to make a guess. So go ahead and type that in. As always, folks, we will continue with this going forward. Thanks for listening. Feel free to shoot me an email. Feel free to reach out if you have any questions at all. Thank you, folks.